So we have the equation for a unit circle. Okay? Let's take a look and see where these trig functions come into play.
You sure that circle? Is that a potato?
Let's all imagine, okay, this is a circle. Okay, so we have a circle, okay? Now we can, notice I put it, the backdrop is the Cartesian plane, okay? We've all studied that. And if I were to have, let's say, a point on the end of the circle, okay? Given that it's on the Cartesian plane, how can I represent that point? I can represent that point as a coordinate, an xy coordinate, right? What does that xy coordinate mean? What does the x mean in that portion of that coordinate? That is horizontal distance from the y-axis, right? And the y is vertical distance from the x-axis, right? Okay, so here, imagine we were to have a array, and we carve out this angle called theta. I can represent this point as being also on a right triangle. Okay. Okay. And this right triangle has a base length of x and a height of y. Perfect. Okay. And a radius of r, and if we're talking about the unit circle, keep our calculations easy, that equals 1, okay? Okay. Here's where the trig functions come into play. The relationships between two particular side lengths and an angle. All right, there are 6 basic trig functions. Let's look at the first one. Okay. The sine of the angle, okay, relates the distance or the length of the side opposite that angle divided by the hypotenuse. Okay. Something called the cosine. Okay. Cosine of this angle, theta, relates the distance of the base as x distance with the hypotenuse. Okay. And the third basic one, there are 6, the 3 others I'll show are just inverses. Reciprocal, I should say. The third one's called the tangent. Okay. And that relates this side length with this side length, y over x. Okay. So, take a step back here. 3 basic trig functions, okay? Sine, cosine, tangent. In these functions, what is the independent variable? What is the independent variable? You're on the right track, not the radius.
What does it mean?
Okay, a sine function does this. I give you an angle measure, and you give me the ratio of side lengths.
Oh.
I give you the angle measure, and you give me, you put it into the function, you pull out a ratio of side lengths. So in that verbal description, what is the independent variable?
Angle measure.
Perfect, excellent. Okay. Very good. So what is the dependent variable?
The ratio.
Perfect.
Side length.
Okay. Perfect. just like we've seen functions before, exponential, logarithmic, quadratic, linear, okay? Same exact idea. You put a particular angle measure into the trig function, it cranks out a measure, okay? All right, one way to remember these, in states, we call it so, okay? Side opposite of right hypotenuse, adjacent side of right hypotenuse, opposite over adjacent. Sort of a way to remember, okay? Good. Okay. Here's a question for you. If given the information we have here for what a trig function is, can a trig function have a negative value?
You mean the value of cosine tangent can be negative?
Yes, can I, for starters, let's break that down. Could I put a negative angle into a trig function?
Yes.
Sure. Right, I mean, the only difference is positives, okay, very good. And could I get a negative value for a trig function?
Yes.
Absolutely, okay. Let's say, for example, I were to have, instead of making the angle like this, I would have gone down like so, okay? What would the sine value be in that case? If instead of I were making, let's say, theta, I make theta 1, what would the sine value be in that case? Negative y, okay? And if I were to do, this gets a little ahead of different angles, if I were to make an angle, let's say, the point falls over here, what would the cosine value be? Negative x. Okay, very good. So I can have could I have a value of 0 for a trig function? Okay, very good. Could I have an undefined value for a trig function? What case would that be? Well, that would be tangent of 0. It would be tangent of where... Okay, perfect. Tangent of 90 degrees. It would be some value where this x component is 0, which would be 90 degrees. Excellent, very good. Okay, so we can have 0 values, we can have undefined values, very good. Very good, very good. Okay. Okay. I said there were 6, but I'll give you the other 3, okay? I won't hold those from you. If I were to have this, okay, take 1 over the sine of theta, I would create another trig function, and that trig function would be called cosine. If I were to take 1 over cosine of theta, I would get what's called a secant theta.
Mr. Green,
Yes.
could I ask you what so and column do that?
Sure. Means opposite side over hypotenuse. A would be adjacent side over hypotenuse. If you're talking about this angle here, okay, the adjacent side is the one that touches it here. Hypotenuse, opposite side. Okay. Okay. All right. Moving right along. And the final, if I were to do reciprocal of the tangent function, I would get what? Something called the cotangent. Okay, very good. Okay. Let's try a couple problems, see how you guys do. Okay? All right. Let's do, now I've gone ahead, the way the book presents it, I think it's better to show it this way. In section 4.3, on page 306, let's try problems 5, 6, and 8. And 13, 15, 17, 19. Okay, so let's try these and see how we do.
So we basically solve the triangle.
Solve the triangle, and we want to figure out the trig function for that angle theta, okay?
Are we getting like all 6?
All 6.
Do we have to get the data also?
No, to get the theta, we use an inverse trig. That's a couple of steps. Yes. You don't even have, well, you don't have to go trying to figure out the angle, you just figure out the value of the trig function. Don't do the inverse trig to get the angle. Well, they want to know sine of theta is equal to what? 6 over 10.
Yeah.
So just write that, sine of theta is 6 over 10.
I have to list all of them?
Mm-hmm.